First of all, there are lots and lots of people had lots and lots of difficulty with the libname statement. And this is really useful for you to get to know because you're probably going to be using other people's data. If you're going to be working with things and maybe none of you care about money and you all want to just help people, but and that's good too. I don't mean to disrespect that, but I have 4 kids I had to put through college, so generally you're going to be working with data sets that other people collected, and you may have, if you're working on a team with other people, like you're working with something like the Medicaid claims database, that has millions and millions and millions of records, you don't have a copy of that on your own computer. And yeah, so you need to figure out a libname statement. So libname, this word can be anything that's a valid SAS name. It could be it could be SAS file if it's all one word. It could be my data, all one word. Many problems people had with this. It's in quotes. The location is in quotes. So many people have problems with that. You need this backslash at the beginning or it won't run. And then you need the entire location. And I know I talked about this before, but I'm going to show you again. Oops. So for this class, under files and folders, you could go to my shared files link and right click on it, pick properties, and it will give you the location. You select that whole thing, including that backslash, and paste it in, and there you've got your libname. So there's the value that goes in the libname reference. Yours is going to be different than mine. That thing in the middle there is your username. This U635 blah blah blah. So I actually did this as a student account, so it looks exactly like what you all found. Actually, you may have the actual name or something different, but you paste this in here between the quotes. So that's the thing a bunch of people had trouble with. You need the backslash, and then you do not, if you want COVID, you don't do COVID, you don't put the COVID data set name or anything. This is the directory where your data are. And then access equals read only is on here because I'm sure you're all wonderful people, but I don't trust you all not to delete the data. So there you go. Lots of times when you start out new, you will only have read-only access. I used to be the senior statistical consultant at the University of Southern California. At least once a month, somebody would call in tears because they were some doctoral student or some new person, and they had deleted something like the Medicaid claims database. And just so you know, pretty much every organization of any size is a backup every night. So just so you know, if you don't have access, equals read only, and when you're starting out, I would recommend you put this in yourself so you don't accidentally delete something and call my office crying. All right, so other little thing, when I said, where are you going to get the data from? This is a little thing. You don't need to do it at all, but it's just a little tip. Put the footnote in there. So there's a footnote statement. You don't have to do this. Future you will thank you. In this, in quotes, I just put where I got the data from. There's I forget whose law it is. There's somebody's law that says any program you wrote over 6 months ago may as well have been written by somebody else. 6 months from now, if you ask me where I got this data, I wouldn't have the faintest idea. So don't need to do that, but it'll help you out. So now in is for the libname statement. So I take this libref is what it's called, which is the word that's going to reference for SAS where to find the data. And I have in.covid, and this is going to give me the contents for the COVID data sets. Now, I could just go ahead and do the frequency distribution. Remember, we're still talking about death rates by race or ethnicity. So I run this. So look at the race and ethnicity down here. We have some 405 people who put they were American. Okay, good for you, buddy. We have one person that put, I don't know if it was Native American or not applicable, so we're going to drop them out. We have a bunch of people that put multiple races. So we have a couple of options. We can include these multiple race people or not. We definitely want to drop out this one person that had NA, and we want to drop out these 405 people who put American because they're just annoying, because that is not a race. Remember, it said clean the data, and I said, what little minion's going to do that for me? One thing you can do, and I'm going over this because I know Francis was saying sometimes you start working in these programs and there's the little things and it's so frustrating you just want to shoot your computer. So here's a couple of them. There's a where statement. Where race ethnicity combined is in, and I'm going to give it just the categories I want. White with a comma. Why? Because obviously this was truncated, and this is how it is stored as race. White comma. So I don't know if I probably said white comma non-Hispanic. White comma Hispanic without the C, black comma, Asian comma, and native. So those have to match exactly how it is stored. So I'm going to go in and do where race ethnicity combined is in white, comma, Asian, comma, black, comma. All these have to be in quotes, and there has to be a comma in between them. And now I can run this. And I have this combined race ethnicity combined times, not really times, but this is going to be the column, the row variable. This is going to be the column variable. The second one's going to be your column variable. And then I have slash, because remember the slash denotes that an option is coming. CHISQ for chi-squared. So I have my result. And so the next question, the null hypothesis is what? Because this is what you're going to have to go and you're Dr. Fauci, and you're standing up there and you're saying, our null hypothesis was, a null hypothesis has the word null in it. It is a statement of null, no relationship, no difference. So there's no difference in death rates between races. That is our null hypothesis. Now, next question, because this week's all about hypothesis testing. Do we accept or reject our null hypothesis? And how do you know?
We reject it.
Yes. And how do you know that?
Because of the value and the probability.
But probability is less than 0.0.
Less than.
Yes. Yes, so you would reject the null hypothesis. And then the second thing I do always is look at, okay, it's statistically significant. That means it's not zero. How big of a difference is it? And then that's the part where I would start looking and saying, well, it's Hispanics have not quite twice, but certainly a 70 or 80% higher death rate than non-Hispanic whites. That would concern me. And I'd also want to start looking at other factors. Like I said, the Hispanic population, I know, just because I do a lot of research in demographics, is significantly younger than the non-Hispanic population. So that makes that higher death rate look even more concerning. But then if you were somebody who was on the other side of the aisle and wanted to argue about this, would say, well, you say that the Hispanic population is younger, which is not just I say it is, but it is. But how do you know it is in this population? And again, that's the kind of question that hopefully you thought of because ChatGPT didn't tell you. So what would I do in that case? Well, in that case, I would do the exact same thing, except I could look at another frequency distribution. By age group. And I hope it was age group like this. Ideally, and this is the thing ChatGPT would tell you too, ideally you would do an analysis of variance by age. That would be ideal. Guess what? The data set doesn't have that data. So here we are. Wow. Something's very strange here. Y'all see it? What is weird about these data? Native Americans are 0.44% of this sample, and they are 100% of the sample under age 9. So that's very bizarre. I don't know why that would be. It may be because I just pulled these 10 million out of 100 million records. So it might be that they were not in random order. But that's very bizarre. So again, when ChatGPT says you should clean the data, you should look at missing data.
Same
so
with
it looks
the
like
Hispanic data under 38,
yeah,
39.
yeah, that's very bizarre. So, like I said, it looks like these data were not pulled at random. So that's one of the things that you'd want to look at is, are these data representative of the population? So those are things that you should be looking at, is not just, is it statistically significant, but are there other factors in these data? And like I said, this comes about next week when we start talking about multivariate analyses. And then are there things that are not quite right about the data? For one of them, if we're looking at, there's a whole different thing to leap into, but if we're looking at medical conditions, for example. So out of these almost 10 million people, 6.5 million of them, we don't have the data on if they died or not. And for 6 million of them, we don't have the data on whether they died or had a medical condition. So these are the data that we have, and we can say, based on this large number of data, this is what we found as far as a relationship between medical condition and death. However, a very large percentage of this data, 2/3 of it, was missing for death, and 60% of it was missing for both death and medical condition. So it goes back to, like I said, at the very beginning of the book, where it talked about what are the confounding factors we should look at, what are the possible sources of bias, and you can get nice little tables and paste them into ChatGPT, or you can get it telling you, you should look at missing data and clean your data up. But how do you do that? So here's some of how you do that.